Welcome to Curiosity. When you look up at the night sky, you are actually falling for a massive optical illusion. We naturally assume the stars glittering above us exist right now, exactly as we see them. But physics breaks that assumption. Light, the very thing allowing us to see the cosmos, has a strict speed limit. This document shows the exact speed of light in a vacuum, a constant designated as c, clocking in at 299,792.458 kilometers per second. Because this speed is finite, every emitted photon requires physical time to cross space before striking our telescopes. Astronomers measure this delay as lookback time. Our present is entirely disconnected from the present of a distant galaxy. We are not looking at the universe as it is today. We are peering into a historical archive of celestial ghosts. Let's test this in our own solar neighborhood. The sun is nearly 150 million kilometers away. If it were to suddenly extinguish, we wouldn't know for over 8 minutes. Pushing further out, our nearest stellar neighbor is the Alpha Centauri system. Its light takes over 4 years to reach Earth. Given that an average star burns for billions of years, a delay of a few minutes or even a few years is negligible. Statistically, the local bodies we see are still burning right now. Our immediate cosmic backyard accurately reflects the recent past. But as we peer deeper into the dark, the math governing what is dead and what is alive drastically shifts. The nearest major galaxy, Andromeda, sits 2.5 million light-years away. The light hitting our eyes tonight left those stars when early hominids were just beginning to walk the Earth. To push past our local group, we rely on instruments like the James Webb Space Telescope to capture the highly redshifted infrared universe. Using these massive mirrors, astronomers have documented high redshift targets like the galaxy GNZ11, recording lookback times exceeding 13.4 billion years. These images show the earliest generations of stars. They were incredibly massive, highly luminous, and burned through their nuclear fuel rapidly, often exhausting themselves in just a few million years. Because their lifespans were so brief, and the light's journey took over 13 billion years, every single star visible in those deep field images is definitively dead. They exploded as supernovae eons ago. At the absolute limit of the observable universe lies the ultimate ghost image, the cosmic microwave background. This data table highlights the parameters of that early cosmos. The CMB is the oldest light we can detect, emitted by a dense plasma that cooled and ceased to exist 13.78 billion years ago. Mapping the furthest reaches of space literally means mapping structures that vanished billions of years before the Earth was even formed. By charting these ancient, dying structures, we can measure the rate at which space is stretching. This record of expansion allows us to calculate exactly where the cosmos is heading. On a macro scale, we are currently living in the active stelliferous era, the age of stars. But the accelerating force of dark energy is driving the cosmos towards its eventual demise. The prevailing scientific model points to a heat death. As galaxies drift apart, star formation ceases, and matter decays, approaching absolute zero. Alternatively, if dark energy increases to infinity, we face the Big Rip, where expansion overcomes gravity, physically tearing atoms apart. A spherical bubble of true vacuum could expand at light speed, instantly overriding the laws of physics and erasing all matter. Regardless of the exact mechanism, the physics governing cosmology dictate that reality as we know it is marching towards an inevitable total erasure. Significant gaps remain in our models. Most notably, measurements of the early universe from the CMB disagree with modern observations of supernovae, a discrepancy known as the Hubble tension. Realizing that the night sky is a delayed archive of cosmic ghosts should not evoke despair or a sense of nihilism. The finite speed of light is a profound physical gift. It grants humanity the unique ability to literally look back through time and witness the dawn of creation unfolding. The cosmic time delay transforms us into the ultimate historians, documenting the origins of everything by simply looking deeper into the dark.